Welcome back to PreCalculus. Today we're going to start looking at the second of 4 conic sections. In the previous 2 videos we talked about circles, and today we're going to start talking about parabolas. Now you guys are all very familiar with parabolas. We've been launching pens and markers across the room for years to demonstrate parabolas, but we're going to look at them in terms of a new type of definition. And just like we had with circles, we're going to look at the definition in terms of all of the points. So the definition for a parabola starts off as the collection of all points. Okay, and so what we're looking at is every individual point on a parabola. Okay, and what's true about it. So the definition then goes like this: collection of all points equidistant from a fixed line and a fixed point. Now, if you think back to the definition for circles, that was the collection of all points equidistant from one fixed point. We still have the fixed point, but now we're going to say equidistant from a fixed line and a fixed point. Okay? Now, I've left parentheses in 2 spots because we give names to the fixed line and we give names to the fixed point. And so the 2 names, the fixed line is called the directrix. So it's spelled D-I-R-E-C-T, so the word direct, with the suffix R-I-X. So the word direct with the suffix R-I-X. And the fixed point is called the focus. Okay? And so what we do is we find all of the points that are equidistant, so that means the same distance from a fixed line and a fixed point. So if I were to draw a fixed line on my little 2-dimensional picture, so this is just a straight line. All right, so this is just a straight line. This is going to be called the directrix. And we have a fixed point that's called the focus. The parabola is going to be all of the points that are equidistant from those 2 things, the line and the point. Okay? So that means, as an example, we know that the parabola would have to start off halfway in between the focus and the directrix, because the 2 distances would be equal. The distance from that, from the focus to this point would be the same as the distance from the directrix to that point. Those 2 line segments would be equal distance. Okay? And then every other point on the parabola, and I'm just going to try to pick a couple here so that you can get a feel for it. So this point, as an example, is going to be on the parabola because the distance here and the perpendicular distance here are going to be equal. We'll have another point, let's say maybe over here somewhere, because the distance to the focus and to the directrix then are going to be equal to each other. And when we put all of those points together, of course we have points on the other side as well, so maybe we'd have a point over here and another point there, but when we put all of those together, when I put all of those points together, we form a curve called a parabola. So every point, no matter which one you grab, let's just grab one way the heck out here somewhere, that would be a point so that the distance to the focus and the distance to the directrix are the same. Those distances, no matter what point on the parabola you choose, the distances to the focus and the distance to the directrix has to be the same. Okay? All right, so that's how we're going to be looking at a parabola as the collection of all points. Now, in terms of the equations, how are we going to know whether something is a parabola? Well, when it's written in general form, and please remember general form is that crazy looking equation we started off with the other day, the ax squared plus bxy plus cy squared plus dx plus ey plus f is equal to 0, the one from the other day. What has to be true about that equation for it to be a parabola? Well, 2 things. The b value has to be 0, so we're not going to have any xy term yet. And then the second thing, a has to be 0 or b has to be 0. They can't both be 0, but either the A or, and I have a typo, sorry about that, guys. I have a typo. Sorry about that, that's my bad. This is a typo. It shouldn't be, I gotta fix that for everybody, sorry. It's gotta be A is equal to 0 or C is equal to 0, not B. A is 0 or C is 0, not both, not both. Okay? So one or the other would then have to be equal to 0. So either the A has to be equal to 0 or the C has to be equal to 0. Kind of a shorthand or a shortcut way to think about that is one of the two squared terms, not both, but one of the two squared terms has to be out of there. One of those squared terms has to be gone. Okay? So that's how we know an equation in general form is going to be a parabola. Now, next we need to know what the standard form, just like with circles, we need to know what the standard forms are going to look like. And we're going to have two standard equations for our parabolas. One, when the parabolas are what are called vertical, and vertical parabolas are going to be parabolas that either open up or open down. We're going to call those vertical parabolas. And in that case, the basic equation, the standard form equation, is going to be x minus h, quantity squared, is equal to 4p times y minus k. Please notice that there's a power of 2 here. There's a power of 2 there, but no power of 2 there. Please notice power of 2 around the x's, power of 1 around the y's. But the equation again, x minus h quantity squared is equal to 4p times y minus k to the first power. Okay? Or we also have what are called horizontal parabolas. And horizontal parabolas are going to be parabolas that either open to the left or open to the right. And for those parabolas, the standard equation is y minus k quantity squared is equal to 4p times x minus h. Again, please notice power of 2 here, power of 1 there. Power of 2 around the y's, power of 1 around the x's. Okay? And then to get ourselves started, we have another point. We've already talked directrix and we've talked focus, but now we've got another point that's called the vertex. And the vertex is going to be located at h comma k. The h and the k come from the parentheses in the two standard forms. And because they're inside parentheses, we'll go through that again. Anything inside parentheses is always opposite of the sign. Okay? And I'll explain what the vertex is in just a minute. There's one other variable, though, that's in our equations that I need you to focus on, and that's this p value that's located in each of the equations. And the p is the distance between the vertex and the focus, the vertex and the directrix. So in other words, it's going to be the point halfway in between the focus and the directrix. Okay, so if I back up to that just rough picture that we had drawn earlier, the point that's halfway in between is going to be the vertex. So this point right here that I'm going to circle in green is actually going to be what we call the vertex. Okay? Now a little more information about that P before we move on. Let me get back to where I was. Now for the vertically opening parabolas, we said that the parabolas could either open up or down, and it all depends on the sign of P. If P is greater than 0, so let me choose my laser pointer. If P is greater than 0, in other words positive, then we're going to have a parabola that opens up. If P is less than 0, negative, then we have a parabola that opens down. Okay? And for the parabolas that are horizontal, either opening left or right, if P is greater than 0, positive, then the parabola opens to the right. And if P is less than 0, negative, then the parabola opens to the left. So we have a whole bunch of information that we have to put together at one time. Okay, so going to be a little bit tougher than circles, I believe, a little bit tougher. I just want to give you a couple of possibilities for the orientation for both vertical and horizontal parabolas. We're going to be looking for, you'll see it on the next screen, but we're going to be looking for Three pieces of information right off the bat. I'm going to be asking you guys for the location of the vertex. I'll abbreviate that with a V. I'll ask you for the location of the focus. I'll abbreviate that with an F. And then we're going to be looking for the equation of the directrix. That I'll abbreviate with a D. And then once we get those, once we get the locations of the vertex, focus, and directrix, then we're going to be sketching in parabolas. We're going to be sketching parabolas in, and they'll either be, like I said, vertical or horizontal. Okay? Vertical or horizontal. Right? And so those are going to be the locations that we're really concerned with. Those are the three: the vertex, the focus, the directrix, and then the graph. Those are going to be the things that we're concerned with when we're graphing. Okay? Alrighty. Excuse me. So, and then the whole idea with the P distance, let me switch colors so I can get you this. The P is going to be, again, the distance from the vertex to the focus and the vertex to the directrix, either vertically or horizontally. P is the distance from the vertex to the focus, vertex to the directrix. All right, and we'll be putting all of that information together. Okay? And so let me just summarize before we actually get into examples. As we move forward with the different types of conic sections, I'm going to be giving you guys lists of information that you're going to be required to give me in any one problem. Now, when we deal with circles, I've mentioned this before, but just to kind of reiterate, when we deal with circles, what I'm going to expect out of you guys is to be able to find the center, the radius, and draw me a decent graph. Now, with parabolas, starting today, when we give you guys the equation of a parabola, I'm going to expect you guys to be able to tell me the vertex, the focus, the equation of the directrix, and draw me a decent graph. So there's going to be 3 things you're required to do when we have circles, 4 things when we talk about parabolas. And the numbers will change as we move along to ellipses and hyperbolas. You'll have different things that you're going to be responsible for. Okay? So let's actually get into a couple and see how we can graph parabolas using this new collection of points idea. Okay? All right, so here's the first example. The equation is y minus 2 quantity squared is equal to 12 times x minus 3. Okay? Now the first thing I'm going to ask you to do is I'm going to ask you to find the equation, or I'm sorry, not the equation, the location of the vertex. All right? Again, go back up to your notes. The vertex is going to be h comma k. Right? And remembering anything inside parentheses is opposite sign. So the x coordinate for the vertex is the opposite of negative 3, so positive 3. And the k, the coordinate for the vertex, the y coordinate of the vertex is going to be the opposite of negative 2, so positive 2. So on our picture then we can locate the vertex 3 to the right and 2 up. And I'm going to put a little v there just to remind you that that's the vertex. Now the next 2 things we're going to find are the focus as an ordered pair, and then the directrix as an equation. Because the directrix is a straight line, it's going to be, for now, either a vertical line or a horizontal line. So we'll have to make up our minds as to what that is. Now to find each of those, to find the focus and the directrix, what we need to do is we need to figure out the value for P. Now, if you go back to the standard forms, in front of the second set of parentheses, in front of the parentheses on the right-hand side, is 4P. Okay? This term right here has to be equal to 4P. So what we actually do to find the value for P is we set whatever that number is equal to 4P. Okay? And then solve for P, in this case dividing both sides by 4. So that means P is equal to 3. So by definition, P is the distance from the vertex to the focus and from the vertex to the directrix. So we know the distance. The distance is 3. Also, we know that the 3, you can tell obviously that the 3 is positive, so that tells us whether it opens up and down, right or left. But how do we know? Well, which form is this? Is this the form of an equation for a parabola that opens vertically or horizontally? Well, when it's the y's that are being squared, this is going to be a parabola that opens horizontally. Everyone see that? Look back in your notes. Because the y's are the squared variable, this is going to be a horizontal parabola. So you put horizontal together with that number, the p-value is positive. You put those two things together. The y's are squared, so horizontal. The p is positive, which then means that this is a parabola that opens to the right. So this is going to open right. And what does that help us with then? That then tells us that the distance from the vertex to the focus is 3, but we then would have to move 3 to the right. So 1, 2, 3. The focus is then going to be right there. And then we'd have to move 3 in the other direction to get to the directrix. So we move 1, 2, 3 in the other direction. And so the directrix is actually going to be 3 to the left of the vertex. So in this case, that's right smack dab on top of the y-axis. All right, so where's the focus then going to be located? 6 to the right and 2 up. And where's the directrix? Well, it's a vertical line, and a vertical line passes through the x-axis, so it says x equals. And where does it go through the x-axis? At 0. And then what I expect you guys to do is try your best to draw a decent picture for the parabola. So I'm going to pick a point that I just think looks to have about the same distance away from both the focus and the directrix. So I'm just picking a couple points, just eyeballing it now, guys, just eyeballing it for now. So I'm thinking to myself, that distance and that distance look about the same. This distance and this distance look about the same. So I'm just going to try and find a couple of those points, and then through those points, I'm just going to do the best I can to sketch in a parabola. Okay? So again, 3 things I'm going to be asking you guys for: vertex, focus, directrix, and a decent graph. All right, so that's going to be the idea. Let's try several more. By the way, sorry about that. My first example, I gave you the equation in standard form right off the bat. My second example, I'm giving you in standard form right off the bat. It matches up to your standard form equations. Okay, so the second example, x plus 3 quantity squared is equal to -8 times y minus 1. Right? Because it's the x's that are raised to the second power, this then means that we're going to have a vertically opening parabola, so either up or down, all right? And you should be able to then tell me the location of the vertex right off the bat, because that's opposite of the values inside the parentheses. So the x coordinate for the vertex is the opposite of positive 3, which is -3. And the y-coordinate for the vertex is the opposite of -1, which is positive 1. So the vertex is going to be located 3 to the left and up 1. So it's going to be located right about there. So I'm just going to put a V, small v in there, just to highlight that. Next, we're going to want to find the focus as an ordered pair and the directrix as an equation. All right, so it's either going to be a y equals or an x equals. But to figure out where the focus and directrix are, we need to know what the p-value is. And so what we do is we set 4p equal to whatever the heck that number is in front of the second set of parentheses. So in this case, -8. How do you solve for p? Divide both sides by 4, so p is equal to -2. Now I need you to put two things together. The fact that this is a vertically opening parabola, together with the p-value being negative. It's a vertical parabola and the p-value is negative, which means that the parabola is going to open down. And if it opens down, then the focus has to be 2 units down, 2 tick marks down from the vertex. And the directrix then has to be 2 units up. And that means it then has to be a horizontal line So let me choose my laser pointer. So the distance from the vertex to the focus is 2, and the distance from the vertex to the directrix is 2. Okay? But the orientation will then have the parabola opening down. And can you guys then tell me the location of the focus? Sure, it's 3 to the left and 1 down. So the coordinates would be left 3, down 1. And the directrix is a horizontal line. A horizontal line always passes through the y-axis, so the equation is going to be y equals, and where does it pass through? The y-axis. It passes through at positive 3. So the last thing we have to do is just get a ballpark idea of what the graph is going to look like. And so I'm just going to do the best I can, pick a couple of points that I think will be the same distance away, from the two, from the focus and the directrix. So I'm just going to pick a couple of points, just eyeballing it, and then I'll be able to sketch my parabola through those. And I'm just going to try that one again. That turned out kind of ugly. So it looks something like that. The whole idea again is that the distances to the directrix and to the focus, those distances have to be the same. For any point, for this point way out here, this distance and that distance would have to be the same. All right? And once you've done a couple, you'll start to get the hang of that a little bit more. We've never done anything like that before, so it takes a little getting used to. Okay? So my first two examples, I gave you the equation of the parabolas in standard form. But now we're going to change up on the last two examples, and we're going to give you the equations in general form. And we're going to make you guys do the work. I'll, of course, be helping you here. But we're going to have to do the work to go from general form to standard form. And it's going to be a little bit different than the circles. We're still going to have to complete the square, but it's going to be just a little bit different than we had with the, with the circles. All right? So here we go. Let's give it a try. So the equation starts off as y squared minus 2x minus 8y plus 14 is equal to 0. And we're going to complete the square to go from general form to standard form. Ready? Whatever variable is squared, put that on the left side. All right, so the y's are the squared variables, so put the y squared and the negative 8y on the left side. And move the non-squared variable, so the negative 2x, to the other side by addition, and any number, the 14, to the other side by subtraction. So whatever variable is squared, put those variables on the left side. Everything else goes to the other side, so the other variable and the number. Now we're going to want to complete the square for the y's, so that forces us to add a blank on both sides. And remember, as long as we add the same number on both sides, legal. All right? And then to complete the square for the y's, remember that means form a binomial squared. The first term is the variable above, so that's a y. The second term we get by taking the number sitting in front of the y and dividing by 2. So negative 8 divided by, negative 8 divided by 2 is negative 4. Now whatever number goes in the parentheses we have to square, so negative 4 times negative 4 is 16. Back up and add that in the blank on both sides. Now we don't need to complete the square for the x's because we don't have x squared on the right hand side, so all we have to do here is put the two numbers together, so negative 14 plus 16 is 2. Okay, so we're almost there. We've completed the square for the y's. But to get it in standard form, what we always will do on every single parabola is we'll factor out whatever's attached to the x, not what's common, even though that's the same thing in this case. We always factor out whatever's attached to the x. So there's a 2 attached to the x, so that's what we have to factor out. Now, just coincidentally, I know there's also a 2 there, but we don't really care what the second term is. We'll always factor out whatever number is attached to the x. And now if you look back in your notebook, now we've put this exactly into standard form. All right, now we're in standard form. Now you can see that the y's are the squared variable, so this is going to be a horizontal parabola. And so you should be able to tell me the location then of the vertex. Remembering opposite signs for the x-coordinate, the opposite of +1 is -1, and for the y's, the opposite of -4 is +4. So the vertex, let me switch to red as I've done on the previous problems, is left 1, up 4. So the vertex is going to be right about there. Now things are going to be really tight on this one. I'm not sure if the problem will allow me to blow this up. In fact, I'm going to blow up the picture as much as I can. I know I'm using up some room, and I'm going to blow that up the best I can. In fact, I'll just go crazy. I'll make it as big as I can. I might have to move this after, but all right, so I'm going to redo that, guys. So I'll put the vertex left 1, up 4. Okay, there's the vertex. Okay, then we've got to figure out the p distance. We've got to figure out the p distance. So what I do is I take whatever the number is in front of the second set of parentheses, and I set that equal to 4p. So 4p is always equal to whatever that number is. So when I divide both sides by 4, that means p is equal to 1/2. So the distance from the vertex to the, let me get back to black, focus is going to be 1/2. And the distance from the vertex to the directrix is going to be 1/2. Okay? So the last thing we have to decide, we already know it's a horizontal parabola, and the p distance is positive, which means this is going to be a parabola that opens to the right. And if it opens to the right, that means then that the focus is going to be located 1/2 to the right of the vertex, and the directrix is going to be located 1/2 to the left of the vertex. All right, so things end up being really tight in here this time. The directrix, the vertex, and the focus. Everything's really tight in there this time. Okay, so to actually find the ordered pairs, we'd have to go 1/2 to the right. So -1 plus 1/2 is going to be located at -1/2, +4. And then since the directrix is a vertical line, it's going to be an equation that hits the x-axis. And it's going to be located 1/2 to the left of the vertex, so it's going to be located at -3/2. And then again, I'm just going to ask you guys to do the best you can. Sketch in a parabola where you'd think every point would be equidistant from the focus and the directrix. Do the best you can. Okay? So a little bit extra work, of course, when we have to do the work of completing the square. All right, and I've got one more of those to try. I know this video is going a long time. I've got one more of those to try. Like always, feel free to pause the video. I'm going to shrink that up so I can get it out of the way so that I can then work this last problem. Okay? So again, we're going to give you the equation of a parabola, but this time in general form. So you guys are going to have to do the work to put it in standard form. Again, the process is going to go like this. Whatever variable is squared, put that on the left-hand side. Put the other variable on the right-hand side along with any number. So the 8y has to move to the right, and the -7 has to move to the right. Okay? Now we want to complete the square for the x's, so we need a blank on both sides. And then I can complete the square for the x's. Remember forming a binomial squared by taking the number in front of the x and dividing by 2. 6 divided by 2 is 3. Whatever number goes into our binomial, we have to square. So 3 times 3 is 9. Back up and add in the blank on both sides. And then when I add the two numbers together, 9 plus 7 is 16. Now we're almost in standard form. The only thing we have left to do is form parentheses on the right-hand side. And we do that by factoring out whatever's attached to the y. In this case, there's a -8 attached. So we factor out the negative 8 from both terms, and what we'd be left with then is y minus 2. And now we're in standard form. And because the x's are squared, you guys can then tell that this is going to be a parabola that opens vertically, and therefore the vertex is going to be, remembering opposite signs, for the x, the opposite of positive 3 is negative 3, and for the y, the opposite of negative 2 is positive 2. Right? And then while we're at it, whatever number's in front of the second set of parentheses, we set that equal to 4p, and solve for p by dividing both sides by 4. So p is equal to negative 2. So we put two things together, the vertical parabola along with the negative number, and that tells us this is going to be a parabola that opens down. Okay? So what we can do is start drawing this. I'll do it in red like I've done the others. So we have to go left 3, up 2. And then because the distance is 2 and it opens down, that means I go down a distance of 2 to get to the focus, and I go up 2 to get to the directrix. Okay? So then the focus is going to be 2 down from the vertex. So we'd have to subtract 2 away from the y, so 2 minus 2 is 0. And the directrix is going to be 2 up from the vertex. And because it's a horizontal line, that means it has to go through the y-axis. And if it's 2 up, that means it passes through 4. And so the last thing I'm going to ask you guys to do then is, again, just do the best you can. Sketch in a parabola. I'm going to try that again. That's a little ugly. That's a little nicer. So that any point would be equidistant from the focus and the directrix. I'll just randomly grab a point here. I tried to draw it so that any point is equidistant to the directrix and to the focus. Those distances always the same. Okay? Sorry this video was so long. I just had to get through a bunch of these examples. Feel free to stop this video, I should say. Take a break, try a few of the problems, and then come back and look at the second video dealing with parabolas. Hope you're having a good day. Talk to you again soon. Bye.